So this is how informations are held in memory. Every object that is stored, for example, inside this space has a specific address associated with it. In Java, everything is passed by reference. When you pass that object into another function or method, it's passed by a copy of the reference. Sometimes people call it value of the reference, right? Because if you make a copy of it and that copy reference is just a memory address. Memory address is what? It's a hexadecimal. A hexadecimal can be converted into a decimal, so you're talking about a value. Just think of how objects get from one place to another and how your application know the existence of this object, because the application knows that there is a memory address associated with it. In Java, and a reference carries this memory address associated with it. And that is how this next object knows where to find this object. So let's talk about direct addressing. This is an example illustrating the fact that you have a char. This char is statically allocated on the stack. This one has a value of A and sitting at this address 572. Every time you're referencing CH is just a label. On the inside, it's actually referencing 572. 572 has this value called A. Word is kind of synonymous to values. Let's move on to the next one. Indirect addressing str_cat. str represents a reference where this cat is located. Cat is actually a sequence of characters. It is an array. So this buffer is 3 characters CAT. This is when a memory address associated with a variable holds the address of location that holds the value of the variables. 320 is where this thing is. str is a class. This class has many information. One of the information is number of characters you have inside this buffer. This is the beginning of that memory address for str. And 320 is a reference to this string object. So this is how you reference an object, how reference variables are used in Java. When you create a reference variables like this, what are you referencing? You're referencing this other address that holds the beginning portion of that instantiated object called cat. And this cat is of type Java string, Java class string. When you get into, for example, linked list, every node next points to the reference variable through the indirect addressings like this. The next node points to a specific location. Inside that specific location, maybe 2 or 3 levels down, points to another next because it's using this indirect addressing. That is what we call reference variable. Here are the 2 basic structuring mechanisms. My circle is pointing to this big object. All circle is an array of type circle, I guess. It is very possible that you can have several objects pointing to the same object. This array basically just stores the memory address to these objects. Circle A points to null. All of the reference variables like this has a default value of null. If you say circle B is this particular object, then this means that you can have a circle B equals this object. This allows you to have this association. Let's move on to the next one. References are memory addresses. Back in C++, reference is kind of like a type and not a type in C++. In Java, it strictly means the memory address, pointing to something using an indirect addressing. This reference to another space inside that memory cloud. Sometimes you can reference these things as links or addresses or pointers. Let's move on to the next slide. References are assignable. A is this and B is this. So if you say A is B, you're swapping the value of it. These are direct value swap. C1 and C2, these are reference variables. So if you do C1 equals C2, C1 is going to be pointing to the C2 addresses. So this is primitive direct addressing, and this is indirect addressing. If you're not careful, you could be referencing the wrong object to retrieve the wrong values. Aliases are references. Date to increments is going to increment the date on one. But if you do that, then day one is going to change. Day one and day two are pointing to the same. So that's what this is doing. So beware of the references. Because when you change one thing, other things will change too. This is a shallow comparisons. You're basically comparing the value of C1 and C2. If the values are the same, you're really comparing C1, the reference, against C2 references. In this case, they're pointing to the same thing, so they're true. If you're doing this, false, because C1 in this case is pointing to this object. This object is different than this object. They have different addresses. So this is going to be false, but this is going to be true. Same thing here too. They are not references. These are primitives. Just comparing whatever is inside the value, because this is direct addressing. Garbage management is done automatically. Whenever a reference is on reference, it will be picked up by the garbage collection. Garbage collector happens automatically, and this makes Java kind of slow at runtime. Arrays are a collection of elements, and these elements are of the same type. These elements are sitting contiguous in memory next to each other. They have to be instantiated, and you can get into like one-dimensional, two-dimensional array. Ideas are the same as in C++. Initialization lists are supported. This allows you to initialize a whole bunch of values at the same time. You can create an array by slotting different class objects inside. It could be any other references in that.